Ever heard the phrase stuck in the doldrums? It means you're stagnant, stuck, not really going anywhere. And it comes from sailors who would get stuck in an area along the equator they called the doldrums. If you're sailing through this area, you better have some oars handy because there's very little wind and you won't get very far. The doldrums are also related to the rainforests along the tropics, the Sahara Desert in Africa, and Mojave Desert in the southwest U.S., as well as the frigid winds of the polar regions. These all come about because Earth spins on its axis, which, as we learned in another lesson, deflects straight-moving winds and creates multiple cells of air circulation across the globe. The northern and southern hemispheres each have 3 air circulation cells. These cells help distribute heat and air across Earth. Each cell is like a wide belt around that part of Earth, and in these belts we get wind, which is horizontally moving air. Where each cell meets is also like a belt, but these are opposite to our cells. They are thin, windless strips that girdle Earth. You can remember which is which because the windy cells are wide and both begin with W. Let's start along the equator. As you might expect, the air is very warm here, so it rises straight up. When warm air rises like this, it leaves behind an area of low pressure. You can remember this because the air is leaving, which creates an area of low pressure. Leaving and low both begin with L. This particular area of low pressure along the equator is where we find our doldrums, a long stretch of stagnant air, and our first windless strip between cells. The warm air rising from the equator also brings a lot of moisture with it, and as the air rises, it cools. The water in the air is pushed out and comes back down as rain. It's certainly no accident that we find the world's tropical rainforests along the equator. This is where all that moisture from the hot equatorial air gets released. The warm air rising from the equator eventually begins to spread horizontally, which creates those wide, windy circulation cells. On either side of the doldrums are the Hadley cells, one for each hemisphere. You can remember the Hadley cell borders the equator because the equator is hot, and hot and Hadley both begin with H. As the air spreads horizontally, we find that it begins to cool even more, around 30 degrees north and south latitudes. When the air is cool enough, it starts to fall back towards Earth's surface, but as it falls, it warms. So if hot air leaving creates low pressure, hot air coming in creates the opposite, high pressure. Because of this, the falling air creates our next thin, windless strip called the horse latitudes. They were named this because, like the doldrums, there is little wind to push ships along the ocean. Legend has it that when this happened, horses on board the ship were either eaten as food supplies went low or thrown overboard to reduce the load. The horse latitudes create areas of hot, dry surface air around Earth. You might not be surprised to learn that this is also where we find the world's great deserts like the Sahara in Africa, the Mojave in the U.S., and the Great Victoria in Australia. Some of the air heads back towards the equator as the warm, steady breezes of the trade winds, but much of it keeps heading towards the poles, creating our next cell, the FERRELL cell. The winds that blow towards the poles and create the FERRELL cells are the westerlies, which you can remember because they come from the west and blow to the east. When the warm, moist westerlies reach about 60 degrees north and south, twice the latitude as our other thin windless strip, they meet up with the cold, dry polar easterlies, which, as you have probably guessed, blow from the east. The polar easterlies make up our third and final circulation cell, the polar cell, and where the polar cell and the FERRELL cell meet is called the polar front. Here, just like at the equator, air rises vertically, and that leaving air creates an area of low pressure. The other interesting thing that these two different temperature cells create when they come together is storms. As we learned in another lesson, fronts are contact areas between two different air masses. When these air masses meet, they're so different that it's almost like they're fighting about the weather, and the storm is like their conflict. The polar front is no exception, and these areas on Earth are well known for their unpredictable storms. Earth spins on its axis, which creates interesting wind patterns around Earth. Among these interesting patterns are global air circulation cells, 3 in the northern hemisphere and 3 in the southern hemisphere. These cells help distribute heat and air across Earth, as each cell is like a wide, windy belt around the globe. Where each cell meets another is also like a belt, but these are opposite to the windy cells, acting like thin, windless girdles. Warm air rises vertically along the equator, and when that air leaves, it creates an area of low pressure. This is our first windless strip, the doldrums. As the vertically rising air cools, it rains a lot of the ocean moisture it brought with it back down onto land, which is why we find the tropical rainforest in this area. At some point, the air starts traveling horizontally, creating the first cell, the Hadley cell. The Hadley cell is home to the warm, steady breezes of the trade winds. As the air of the Hadley cell begins to cool even more around 30 degrees north and south latitudes, it falls back towards Earth. Air coming back creates the opposite situation from air leaving, an area of high pressure, and our next windless strip, the horse latitudes. Similar to the doldrums, the horse latitudes are a terrible place to sail, and along the strip of warm, dry air we find the world's great deserts. Some of the air falling from the Hadley cell continues to travel to the poles, creating the second windy belt, the FERRELL cell. In the FERRELL cell we find the westerlies, so named because they blow from west to east. The FERRELL cell meets up with the third and final windy belt, the polar cell, around 60 degrees north and south latitudes. The polar cell is home to the cold, dry polar easterlies, which blow from east to west, and when these meet up with the warm, moist air of the FERRELL cell, they create the polar front. This is our final windless girdle on Earth, and along here we find many storms because when two different air masses meet, they have a difficult time agreeing on what the weather should be.